turbo engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
Questions. Research.
technology. Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to this week's Naked Scientists, the programme that brings you the latest breakthroughs in science, technology and medicine. I'm Chris Smith.
And I'm Will Tingle.
And in the programme this week, we're looking at our planet's satellites. With thousands of the things in orbit and more on the way, we're examining some of the surprising capabilities that satellites have, including being used to create new alloys in orbit.
The Naked Scientists podcast is powered by ukfast.co.uk.
Much of our daily lives is made possible by the placement of objects orbiting our planet, from GPS to weather forecasts, and even your bank's ATM wouldn't be able to give you your money and function properly without a time code from space confirming when your transaction took place. So this week we're going to explore whether the increasing numbers of satellites up there is becoming a problem, how we can use the satellites we do have to spot potential disease outbreaks before they even happen, why space weather is a threat, and even how one company are planning to forge metals aboard satellites and make things in microgravity for use back here on Earth.
The first artificial satellite was Sputnik 1, sent up by the Soviet Union in 1957. Since then, the number of satellites in orbit has exploded. In fact, it's up by nearly 12% in the past 18 months alone. And the United Nations Office for Outer Space Affairs now estimates there are nearly 8,300 satellites in orbit, although admittedly only half of them are actually active. To learn a bit more about what's whirling around the Earth above our heads, I went to see the University of Cambridge's public astronomer, Matt Bothwell.
a satellite in the simplest terms is just something that orbits around something else. So they can be made by humans, like the Hubble Space Telescope is a satellite of the Earth, but the Moon is also a satellite of the Earth. We call it a natural satellite. The Earth is a satellite of the Sun. It's anything that orbits something else is a satellite of that thing.
And when we talk about orbit, how does a body, a celestial body, or a man-made creation, how does that enter orbit?
Douglas Adams has this definition of flying where he says it's the art of throwing yourself at the ground and missing. And that's kind of what orbiting is. Orbiting is falling in a circle around the Earth. So the Hubble Space Telescope is going in a circle around the Earth, or very close to a circle around the Earth. And it's always falling down. It's being pulled down by Earth's gravity, but it's also going sideways so fast that as it falls, the Earth curves away at the same rate, and it ends up just falling in a complete circle.
From all accounts, it does sound like we're perhaps hitting maybe a critical mass of the amount of satellites that we currently have in orbit around our planet.
Well, that's exactly right. There are, of course, thousands of artificial satellites orbiting around Earth right now, but we are entering this era where we are looking to have that number increased by orders of magnitude. Listeners might have come across Elon Musk's Starlink project. They plan to put tens of thousands of satellites in orbit and blast down mobile internet around the world. But even Starlink isn't the only game in town. There are various governmental agencies and other private companies that are looking to do the same thing. We could very feasibly have 100,000 artificial bodies orbiting the Earth within decades.
And that presents problems in terms of space junk in orbit, but it also presents problems in terms of trying to look up into outer space.
It really does, yeah, because these satellites are all reflective. Anyone that's seen the International Space Station go over will know that. You can see the ISS passing over, and it looks like a pretty bright star as it flies around the Earth. The idea of there being 100,000 of these, it would be completely catastrophic for our views of the night sky. And I think that's bad for everyone, honestly. It's bad for professional astronomers, because as we're trying to take our images of the distant universe, if there are thousands of satellites getting in the way, it's going to be really hard to remove those contaminants in our image and get an unblemished view of the cosmos. It's also bad for amateur stargazers because they just want to get their nice pretty pictures of the night sky. But I think it's also just bad for everyone. The night sky is this sort of universally human shared resource, right? Where you can all look up and we can all see the night sky and all wonder about the universe. And I sometimes feel that putting satellites around the night sky, it's a bit like stringing power cables across Yosemite National Park or something. It's like the desecration of a beautiful natural resource.
Satellites, man-made satellites are not huge, and the night sky is very big. So is it really that much of an issue, all these satellites whizzing about above our heads?
It really is, because even though artificial satellites are not very big themselves, they do have these giant solar panels which are very reflective, which makes them very bright. And if there are just so many of them, they will get very crowded up there. You can even see it nowadays. There are astronomers right now going to professional telescopes and taking images of the night sky, and the images that come back are just crisscrossed by trails and streaks and lines from these artificial satellites that completely ruin the image. And that's only in optical light, the light that we can see. It's potentially much worse in other wavelengths. For radio astronomy, for example, these satellites, especially the mobile internet Starlink type satellites, are going to be blasting down wireless internet, which is going to be great if you want wireless internet in the middle of the Pacific. But it could be potentially that there'll be no way to do radio astronomy from the surface of the Earth, because we're just going to be completely blinded and deafened by the signals from these satellite fleets.
So does that then create this potential catch-22 of we have all these satellites in the way as we're trying to look up, and we have to launch more satellites in order to get a clearer picture?
That could be the case. So for optical astronomy, there are ways of carefully removing the streaks, which are not perfect, but are better than nothing. But for something like radio astronomy, then yes, the answer might have to be going to space, and that could be using yet more satellites, although it'd be an incremental increase, right? I mean, if there's 100,000 satellites causing problems, putting one extra won't be a big deal. The other alternative is to go somewhere that's not the Earth. There are these long-term plans to build a radio telescope on the far side of the moon. The Chinese Space Agency landed a probe on the far side of the moon a couple of years ago and measured the radio environment, the idea being that's the first step in the ultimate plan to build a radio telescope, because that would be fantastic. That's the quietest place in the universe, radio-wise, because there's thousands of miles of rock between you and the noisy Earth.
Presumably there's no easy fix for removing the amount of satellites or junk around the Earth, otherwise people would have thought of it, but do you know of anything that's in play right now that might help make our atmosphere a little bit less crowded?
I don't think there's an easy fix unless you're a supervillain. You're happy to start sort of blasting down satellites with high-powered lasers. There's two different issues here, right? There's space junk versus the artificial satellites that are intended to be there. And there are plans to get rid of space junk. So space junk, as listeners might know, are the sort of the debris that orbits around the Earth. It's everything from discarded rocket boosters to fragments from collisions of pieces of equipment. And there are, we think, thousands of pieces of this space junk orbiting around the Earth. And that is a problem. These bits of space do have to be removed, whether it's by a laser or by a big net or something like that. But in terms of the artificial satellites, I don't think China will be very happy if we start blasting down their communication satellites. And in fact, the problem is only going to get worse. There are very few binding laws when it comes to launching stuff into space. It's a bit of a legal Wild West, and that's why a private company like SpaceX can just launch thousands upon thousands of satellites, and there's very few ways to stop that from happening.
So the future of satellites is only set to increase then?
Yeah, I think the future of satellites is more satellites.
Matt Bothwell.
Another potentially catastrophic consequence of an increasingly clouded sky is the phenomenon known as the Kessler syndrome. With more and more satellites orbiting our planet, the odds increase dramatically of something hitting one of them and creating a cloud of debris that then, in turn, unleashes a chain reaction a bit like a satellite domino effect that can destroy the whole lot of them. The idea was first posited in a 1978 paper authored by Robert Kessler, after whom the effect is named, which went on to say satellite collisions would produce orbiting fragments, each of which would increase the probability of further collisions, leading to the growth of a belt of debris around the Earth. Now, it's important to stress that there isn't so much a ticking clock as there is a need to better account for the amount of material that we have put there in orbit and that we're planning to put there in orbit. We might be some way away yet from a cataclysmic chain reaction of satellite destruction like that, but it's yet another challenge for us to face as we continue our journey and our expansion spaceward.
As well as helping us to talk to each other, gaze out into space and, as we'll hear later, even forge new alloys and manufacture things in microgravity, satellites can also afford us a powerful bird's eye view of what's happening here on the Earth's surface. And by collecting the right information, we can predict not just the weather, which we're able to do with uncanny accuracy these days, but even complex patterns of changes in the behaviour of the land and sea that predict outbreaks of diseases.
One such disease is the diarrheal illness cholera, which is caused by Vibrio bacteria, and it's currently showing a big increase in cases around the world. Thankfully, the University of Maryland's Rita Colwell has been at the forefront of a way to spot where this is likely to happen weeks in advance. She uses satellite images of sea surface temperatures together with the colour of the water, which indicates where the plankton that carry cholera are, to detect where the bacteria are flourishing in the water and therefore where the hotspots for subsequent cholera outbreaks are most likely to be.
Satellites with the sensors that are attached can provide information about human health and advance warning of conditions that might be adverse to human health. We have learned that there are many factors from the environment that direct or control infectious diseases. And if we're able then to measure these different factors, sea surface temperatures, chlorophyll, plant vegetation, which are all related to the infectious disease, then we're able to be forward-looking in positioning medical supplies and medical personnel and vaccines and safe water to prevent these diseases from becoming epidemics.
Is the resolution of the imaging we have good enough to do this meaningfully?
It's fascinating. When I first began using satellites, my hypothesis that we could actually predict the risk of cholera, this was 23 years ago, we had to measure a mile square off the coast of the Bay of Bengal to correlate with the cases of cholera. Today, with the very sensitive satellites, we can actually measure the temperature and the presence of chlorophyll in a square meter of water, a pond or a river. So the sensitivity over the last 2 decades has been extraordinary.
Goodness. And how do you connect those measurements you're making, the temperatures, the colour of the water, the greenness, the chlorophyll, with a risk of a disease like cholera?
The discovery we made, which was very contentious at the time, was that the bacterium that causes cholera is naturally occurring in the environment. The bacteria play a role in carbon and nitrogen cycling and have the capacity to break down the shell of crabs and shrimp, lobsters. And the biggest surprise of all was that the bacteria, just as we have bacteria that are part of our skin and in our gut, so do crabs and shrimp and this little copepod, which is a microscopic animal that comprises a major component of the marine plankton.
You're saying that the cholera bacterium is naturally living inside those animals?
It is indeed. It's part of their natural bacterial flora. And that was very controversial. First of all, that the cholera bacterium is naturally occurring, because it was believed by physicians until the 1950s and 60s as an absolute dogma that person-to-person transmission was how cholera occurred.
How do you link then the surface temperature of the sea, the greenness and so on, telling you that this bacterium which is in the guts of these other animals that are also in the sea is going to then start causing problems in people?
We were able to analyze the phenomenon that in Bangladesh in the spring and fall, there are major outbreaks, and this has gone on for years. And we were able to show that by measuring by satellite the chlorophyll plus sea surface temperature and sea surface depth, in other words, the height of the seawater, which all of these factors play a role in cholera because the bacteria become very abundant when the plankton is blooming. That is, when the plankton respond in the spring to the very warm temperatures of the atmosphere, the sun being brighter in the spring, and these plankton become very abundant. And so by measuring the chlorophyll, we can begin to measure, if you will, the increase in the numbers of vibrios, that these bacteria that cause cholera.
So putting it together then, you're saying you can see the sea surface temperature go up, you can see the plants responding and becoming more green. If there are more plants to feed more of the animals that have got the cholera bacteria, you'll get more cholera bacteria. And when you put that with a high sea surface level and a flood, you've got an opportunity for people to catch it.
Absolutely. By virtue of the flooding that occurs in the spring and following the monsoon season, these interactions of the bacteria and their host, the plankton, responding to these seasonal changes are directly correlated with the outbreaks, particularly in Bangladesh, where unfortunately access to safe water is not as available as it is in Western countries. When you are taking your drinking water and your household water directly from ponds and rivers, then you're really susceptible. This provides a warning system, an early warning system. And in fact, that's exactly what we provide now for Yemen and Ethiopia, where they are suffering outbreaks of cholera. We're able to provide every month a 4 to 8 week prediction of the risk of cholera and in specific geographical regions of the countries so that a very efficient location of medical supplies and personnel that can treat cholera quickly and prevent the epidemic becoming serious and spreading, we're able then to use satellite sensing as a public health tool.
Thank you very much to Rita Colwell.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
You're listening to The Naked Scientists with me, Chris Smith, and with Will Tingle. And this week we're looking at the science of satellites. In a moment, why microgravity and the stable temperature environment means space looks set to be the new manufacturing site for making metals and other fancy materials in the future. But first, the space above our planet might seem cold and empty, but there's a 1,000,000-mile-an-hour maelstrom whipping past the planet all the time. It's called the solar wind, and it's a flurry of charged high-energy particles ejected constantly from the sun. Now, most of these are batted harmlessly away by the planet's magnetic field, shielding us and our 8,000 satellites. But sometimes the sun erupts something far more forceful and far more dangerous, and which can wipe out a satellite in just seconds. And here to explain this threat and what we can do about it is former NASA intern and guide at the Griffith Observatory in California, Rosemary Williams. Rosemary, what are these destructive entities?
So what you're probably thinking of is a solar flare. So a solar flare happens when the magnetic field lines of the sun, they get all twisted up. The magnetic field lines of the sun are already very, very chaotic, and sometimes they can get twisted up. And when that happens, large bursts of energy are ejected from the sun. If we are in the path of that large burst of energy called a solar flare, it can impact things like satellites. Auroras on Earth might be stronger, and in very, very extreme cases, it can take down satellites, their communications. It can impact radio, GPS on Earth. So, ranging from very, very small solar flares that happen on a daily basis to the larger ones, like the Carrington event that happened in the late 1850s, that if it happened today would be very devastating. But that's kind of the big one that we think of.
Are these solar flares effectively the solar wind on steroids, or are they a different effect?
I think that they are a bit different. The solar wind just happens as charged particles, these ions from the sun, are just kind of getting blown away. But the solar flares happen when you have this twisting of the magnetic field that causes the ejection, sometimes of matter, that's when it's called a coronal mass ejection, but sometimes of just radiation or light, which is a solar flare.
And why is that deleterious for our satellites?
A few things. The first, when you have particles that are moving that have a charge, it creates an electric field. And so when you have these particles moving past the sensitive electronics on your satellites, it can mess up those electronics. It can cause communications to go down just because they are, quite small. And so being overloaded with all of that energy can be very detrimental. The second thing is that these charged particles are bombarding our atmosphere. And they actually ionize this upper part of our atmosphere called the ionosphere. It absorbs all of this energy. And when you have a very intense solar storm, a lot of those particles are ionized. And what that does is it kind of thickens up the atmosphere that the satellites are traveling in. Satellites are going to be interacting with particles on a daily basis, but not very many. But when you have these huge solar storms, it makes that ionosphere thicker, which causes drag of your satellites and can actually cause them to deteriorate in orbit and crash back down to Earth, which you also really don't want.
Of course. What can we do about this then? Is there anything that can physically be done either to detect it's going to happen and give us some forewarning or stop the consequences?
So there's a few things that you can do both for satellites and astronauts that are in space and for the people who are down on Earth. So for satellites, what they do to protect from solar flares, especially if they know that they're going to be up there active, sending back data during a period of high solar activity, is they are going to work to shield those sensitive electronics with aluminum, just to protect those aspects. And the second thing is if there are astronauts that are at risk for getting hit by a solar flare while they're up, in the ISS, or if we are going, on the Artemis mission that's going back to the moon, those astronauts are not going to be protected by the Earth's magnetic field. So they're going to want to, reinforce those ships, make sure that there's good radiation protection. NASA and ESA are constantly surveying the sun, looking for solar storms, solar flares. And you can kind of predict when those are going to happen by looking for sunspots, which are these darker areas on the sun. And they signify kind of a lot of activity surrounding the magnetic fields. And when you have a lot of activity with the magnetic fields, you are going to get solar flares, coronal mass ejections, all of that.
How much warning might we get when we're doing this sort of space weather forecasting, where you were saying that astronomers are keeping an eye on what the sun's up to for danger or warning signs? How much lead time when we see those signs before one of these things could be coming our way?
I'm not sure on the exact amount of time. I mean, I know that it takes light about 8 minutes to get from the sun to Earth, but I assume that scientists that are studying the sun are going to be able to predict maybe like a couple days in advance. But beyond that, I'm not exactly sure.
Is that enough time to put in place the sorts of mitigations you've been talking about?
So that's not, which is why it's really important for us to be proactive about this kind of thing, because solar flares and coronal mass ejections are inevitable. And so we need to prepare for these events.
It's just that we've exported so much of our life into the heavens now without us even realising it. I gave the example of the ATM machines, which are in cahoots with the GPS system just to get a time code so that they know when they're dispensing your money, and they can't work without it because otherwise people would be ripping off the bank. We've got stock exchanges trading shares, and they're doing those accurate trades based on time signatures from space. Those are just two financial examples. You can just imagine if this happened and we've got the sorts of satellite burden in space that Elon Musk wants to see there, we will inevitably have exported even more of our life heavenwards. It could get really nasty quite quickly if something went wrong, couldn't it?
It could get very nasty. My astronomy professor would always refer back to, you could live without your cell phone potentially for a couple days, maybe even weeks. But the thing that's really going to hurt society is living without refrigeration. We really rely on being able to have access to fresh food, and that in the event of a solar flare coming in and taking out a power grid, if it's not prepared, that's the thing that we really need to focus on, is making sure that people still have access to fresh food and water, not even necessarily like the laptop or cell phone aspect of it, just kind of our basic human needs.
Thanks, Rosemary. Rosemary Williams there. Now, space isn't just useful for observing our planet or the billions of stars in the universe. It could also hold the key for the next big breakthrough in materials construction. That's the thinking behind the Welsh-based company SpaceForge, as Will Tingle reports.
SpaceForge were one of the satellite companies whose progress was marred by the anomalous failure at Spaceport Cornwall at the beginning of January. However, they remain undeterred. Their mission is to use the space above our heads as the site of, as they put it, the next industrial revolution. They're planning foundries in space to forge new alloys and make products for use here on Earth. But why? I spoke to co-founder of SpaceForge, Andrew Bacon.
I mean, manufacturing in orbit is an old idea. Ever since the Apollo astronauts made coffee on their way to the moon, we've been trying to make things in space. But like all good ideas in space, it was kind of thought of way back in the 60s, trialed in the 80s and 90s, but it's only really now that it's possible to commercialize it.
And what sort of materials would benefit from being made up in space?
So anything that's crystalline has a massive advantage of being made in space. Crystalline materials include alloys, semiconductors, but also proteins, and in some cases, even vaccines. So why is this? So in space, there's two main things that are affecting crystal growth. Contamination. So crystals are generally very sensitive, particularly semiconductors, but alloys as well are very sensitive to contamination. So If oxygen gets into the environment when you're trying to make new material, it's going to try and oxidize that material, which can make it quite brittle. In space, there's barely any oxygen at all. It's what we consider an ultra vacuum, which is something that's very hard to create on Earth. But in space, it's there for free. You just open a door or open a valve. But the big one is microgravity. So what microgravity does is it removes buoyancy. So generally, when you're trying to grow crystals, you're usually mixing two materials together. And if you think in terms of an alloy, so if you have a very dense metal like lead and you mix it with a less dense metal like aluminium, what's going to happen on Earth? The buoyancy is going to push the aluminium to the top. It's going to push the lead to the bottom. In space, there is no buoyancy. They're going to mix together and just be held together due to surface tension and mix much more thoroughly. So you end up with a very homogeneous material. At Space Forge, we're developing uncrewed manufacturing satellites that are dedicated to one process at a time. They go to a much higher orbit than the space station because the atmosphere is much thinner. And yeah, they'll be controlled from the ground. Most of the time, it'll be like a furnace that you switch on. And as long as it's got the right temperature, it's fine. You leave it and it will have some level of intelligence to shut itself down if something unexpected happens. But other than that, yeah, they'll be controlled from the ground. There'll be a little bit of robotics maybe for moving materials around. And this is the most efficient and most cost-effective way of doing it.
As I'm sure you're aware with the whole Spaceport Cornwall incident, unfortunately they didn't quite make it up there. How would your satellites and probes, how would they make it to space?
The key thing about launch is people tend to focus on the cost of launch. So the dominant cost is mainly in the satellite. So when you're looking at launch, it really does make sense to make your satellite compatible with as many different launch vehicles as you can, because if you put all your eggs in one basket and just concentrate on one launcher and that launcher has a problem, it's not like cars where if there's a crash on the car, they don't take all those cars off the road and find out what went wrong. Whereas with a rocket, if it has a failure, that rocket stops flying for 6 to 12 months. Being compatible with as many different launch vehicles as you can is usually the best way to go. You've got to look at what your options are and make sure you're compatible with them.
Whenever we talk about things orbiting our planet, inevitably the subject of space junk comes up. Obviously, we want to minimize the amount of stuff we have floating around the planet at any one time. So with that comes the question of the circular economy. How does that fit into satellites? Is there a renewable element to the things that you're putting up into space?
Satellites are really expensive. And the reason why is because generally you design a satellite to last 5, 10, 20 years in orbit with no maintenance. We don't go up there and fix it. So that means we tend to put a lot of redundancy and do a lot of testing, and that makes them expensive. Now, imagine a different way of approaching satellites where if we could bring them back, if it had a failure or it was getting old or it needed an upgrade or we wanted to maybe move it into a different orbit but we didn't have enough fuel, if we could bring them back to Earth and we could repair them or scrap them but use the parts that still work, that would be a very different looking space industry. But it's something that hasn't really happened to date. But ultimately, for the space industry to really grow, we have to get into a new way of working, which is the bringing back of satellites intact, becoming the norm. Because once you are able to do that, space debris basically goes away as a problem. And then you're building a whole additional economy around the refurbishment, repair, and relaunch of satellites, which is something that doesn't currently exist, but I can see satellite repair person being a job in the future.
Making new materials in space sounds like a promising direction, but surely the elephant in the room is how do you get the raw materials up there and the manufactured materials back down here to Earth? The raw materials get launched inside the satellite and are processed internally, and Spaceforge's idea of getting the satellite and the finished product back down is by using, quote, their proprietary reusable re-entry technology. If you want to know what that consists of, Spaceforge are currently being vague about how this will work in practice, for the moment. But with the subject of the circular economy comes the subject of the environment. So would the continuous launching of satellites and the carbon emission that would entail have a detrimental impact on the planet?
Spaceforge, we want to be a carbon negative space company. How is that possible? When you think of a space company, how can it not be anything other than polluting? But what we're doing is we're using the space environment to make new super materials that are stronger, able to work more efficiently at higher temperatures, being able to increase the efficiency of electronics and move to sort of next generation control systems and communication systems. We don't have to be making huge turbine blades in space. What we need to be doing is making things like stronger bolts so that the green tech industry on the Earth can use that to make more efficient wind turbines. And so then you think about the value of that bolt has enabled a bigger, more efficient wind turbine, which means that you're getting more out of your renewable energy.
Do you see this scaling out to be a multinational worldwide thing? And realistically, what timescale could we expect?
So we're confident this is the next industrial revolution. In space manufacturing for Earth, or as we like to call it, space to Earth manufacturing, probably in the next 10 years, will probably be the biggest space market. Bigger than Earth observation, bigger than communications combined. I can completely foresee a future where pretty much everything we need in what will be a very advanced economy can be made in space, and we can leave Earth for living, not building. In the next 5 years, we expect you to be interacting with something in your daily life that has a space-made component in it. Now, it's probably not going to be in your mobile phone, but it might be in the electric train that you're traveling in, cell tower that you're communicating with, the data center that you're interacting with, or maybe even the grid that you're getting your power from.
So, the alloys of the future could well come from above our heads, with Spaceforge paving the way. And whilst they're playing their technological hand pretty close to their chest, it's not hard to be drawn in by their optimism and confidence. So, watch the space.
Andrew Bacon, co-founder of Spaceforge. And that is it for this week. But next time, do join us again, because we'll be getting our teeth into the end of veganuary and a look at the global food system. An awful lot of resources are consumed in the process of keeping us all fed. 38% of the land on planet Earth is used just for farming, and that depletes our water supplies as well as the nutrient contents of soil. So how much of a difference would it make if we all went veggie? Would it impact on climate change? And would this affect the worrying slowdown in the decline of global hunger? We'll find out next week. And if you have any thoughts, comments or feedback on that or other subjects we've covered here on the programme, do of course get in touch. It's chris@thenakedscientist.com. The Naked Scientist comes to you from the University of Cambridge's Institute of Continuing Education, and it's supported by Rolls-Royce. I'm Chris Smith. Thanks for listening, and until next time, goodbye.